Hello, hello, hello. Welcome to the stream. Have a nice and wonderful Wednesday evening, and yeah, let's continue a little bit with our Cubical Marching Squares test case. And then, yeah, today let's see that we can get maybe something more sophisticated than just like this test GUI UI. So basically extracting from a real volume source. And if that works, we might... Yeah, I think first we will then add the adaptive resolution maybe. And once we have that, I will... Sorry, I got a weird... Okay. Spam message. Yeah, and then we add the adaptive resolution, and then I will look at how we can maybe move that to the GPU. And with that as well, painting of the terrain. Alright. So we need to sample our volume in like a certain interval. Question is, how would be the best to do that? Source, no, volume, tree. I guess. We could probably hack it together. We don't necessarily need to build it fully within the volume library. The other way would be what is that? Is that even used? I guess not. But I think that was probably... That was actually maybe what we intended here. But I'm not sure if that's actually what I intended there. Hold on. I mean, we could put that in there. Maybe we try that. Let me quickly Move that, all of that away. Then let's do using namespace Onyx. And then we could run that here, right? If we want to. Oh, cool! I mistyped that. So basically, if we want, we can run that. I think it's that. What a mouthful. Alright. So let's see. Let's create a volume source here. For example, well, actually a CSG sphere is probably the easiest one. And let's put it, let's make it 5, I don't know. And place it, yeah, basically in the center of the word. And then we create a volume chunk CMS. Potentially. Now we have Morton Code 3D. Let's do less than. Does that even make sense? Hold on. Yeah, let's do. Let's do 100 times. Well, let's do 10 times 10 times 10. That's already kind of big anyways. Although that's radius, so let's do 2.5 and then we are 5 meters. And then this covers a range of 10 times 10 times 10. And I think if we Morton code Morton of I, what does that do? Is that even correct? Yeah, I do think that might be fine. And now we do CMS chunk. set hermite data on I. Right, or do we need to get the Morton thing out? We might want to encode actually, hold on. We might want to actually do... Let's do a naive loop then. Because then we can encode it, I think. X, X, and X, and I mean that is not nice, right? But what can you do? Then we go in and have 4Y, Y, and Y. And we go sad, sad, and sad. Let's make this nicer. Because I don't really like that. Wouldn't be that. And then Morton code is Morton code 3D encode XYZ. 64. And then we set the hermite data on the Morton index to be whatever we sample at that position. Basically sample sample resolution. Let's do for each unit 10. So actually we need to increase that, right? Or do we? Yeah, I think we do. I think that's our sample count. I think. And this is our sample thing. And then we do the position is X times our sample resolution, where 1 divided by our sample resolution, basically. Actually, that can be, now we can do that. And this can still be a U32. No, we don't need to do that. And then here we have the inverse sample resolution, and we can just do a multiply here. We can do sphere, get value and gradient, add that position, and we set that as the Hermite data. And then how do we do that? And then I have individual sample points. Which is fine, but then I need to get the cubes of that, right? Can I just brute force it maybe? But maybe that is stupid. I mean, basically I then go in the Morton order, right? I think. To get like the best performance for that. So basically we go U30 or U64 Morton index is 0, and then Morton index is less than our CMS chunk. Basically get Hermite data, but like the length. Although the length we kinda have, right? That should be the length. And now what we can do is we can do this. Morton index is Morton raw index, and then we can vector 3f decode is this. Oh, that's a static one. But do I need that actually? Oh yeah, I might need that. Where vector U3 U32, I think. Or actually U64. Then we corner decode position at 0, position 1, position 2. Isn't that how it should work? Oh, well, I think actually, sorry, that was what it's complaining about for sure. Oh, is it 32-bit in out? Oh yeah, okay, that makes sense. And so we have that. From that we can get our word position. So that's a vector 3, yeah. And I think what we can do is exactly. So we want 1, the positive x, and 0 that direction. Did I mark it as no discard? No, I didn't, but okay. Corner 1. Corner 2. Or we basically do that. And we do it in the same order that we have it here, right? So basically that's 0, 0, and then we do 1, 0, 0, yes, and then 0, 1, 0, 1, 1, and then 0, 0, 1, 1, 0, 1, and then 0, 1, 1. And then 1, 1, 1. All right. Morton code, Morton index, corner 0. And then one, two, three, what? 3, 4, 5, 6, 7. And we basically do that. And now we have vector 3f. Basically we construct this from that. So what we do is word position corner 0. Now we do that more times, right? 8 times. One. Why did I not add here one? Okay. 3, 4, 5, 6, 7. Man, I instantly did it the right amount of times. How did I do that? And oh, we need that as well everywhere. Could probably do a nicer like a lambda for that or something like that, but whatever. Maybe we do that. Nah, we are committed now. We do it if we have to fix something. Okay, so we have that. And then we get the hermit data for all of them. Basically volume chunk, whatever I called it, CMS chunk. Get hermit data for Morton code at corner 0. Did I not have a U64 conversion? Oh, okay, I need to maybe call. Those can't be static anymore. One, 2, 3, 4, 5, 6, 7. Well, that would be correct, but I guess it's not. Ah, it's not. Never mind, I'm missing one. Then that doesn't work, I guess. Okay, hermit data. Oh, okay. Beautiful. Why ever we did that abstraction, but okay. Oh, okay. Then I don't need that. Never mind. Perfect. So we have that. Then let's run our cubical marching squares on that. Right. And then we don't do that, we do this. Trace segments, which we should do destruct outside, that's fine. And why did I copy that? To like I can't remember again. Yeah, we need to do that fortunate step here. Let's even make it clear that that's useless. And the last step would be we go over that and add it to our mesh. So we do that. Now we do that. We have a mesh builder outside here. And we don't care about that. Just care about that exactly. I think, yeah, that's actually kind of perfect. And I don't really care about the normal right now. Even though I think I would get that out. Right? Or not. Or maybe not. Because I'm not outputting that as part of the line segment. We could. But for now, let's leave it. I'm more curious if we can get a mesh out. And we don't really need the normal anyway. Because we don't really have any lighting anyways right now. And well, actually I'm just curious how many mesh vertices we have afterwards here. So let's do that. Will horribly fail probably. I don't think that this will compile at all right on the first try, but okay, maybe it does. But it definitely died a horrible death. Oh yes, makes sense. So we need to, where is our CMS chunk here? We need to initialize that by our sample count. As all of that doesn't really work. Maybe it still doesn't work. God damn it. Yes. 10 times 10 times 10 and then the sample resolution. Still not. So that's in every direction. Oh, maybe I need to, hold on, maybe it's Maybe it's that. I think it's actually that cubed, right? I think that's more correct because we sample in each direction. The sample resolution. Still not. God damn it. That's still too much though, I think. I think that still suffers from the same issue, probably. Yeah. Why? Okay, let me think. Isn't that 100? Yeah, exactly. And 100 times 100 times 100. That should be how many samples we have. And then here. You know what? We just make that by a factor of 10 bigger for now and see what comes out. Because I think it's because of the Morton index, how it's aligned, that it doesn't work. Okay. Where do we crash here? Normalize, length is 0. What? So edge crossing 2. Are the edge crossing normal? It's a 1. So the normal y index, what's y index 1? So normal on 1. And x index on 2. So 0 and 0 is pretty much 0. Do we handle the case where that's 0? I mean, how should that be handled? You know what? Let's just do that. I'm not sure if that's correct, but we will at least guard the 0. Oh, yeah. Probably doing it wrong again when we access it. Yeah. So that is basically wrong if resize. Let's just if volume chunk something is wrong with that Morton code, or I'm not sure, but whatever. Where is my volume thing? Then we just break, basically. That might still not be enough because we might exceed it here. In which case we probably have to handle that, but let's see. Create member function. I don't think that this will work, yeah. Because we probably hit it somewhere else. Which one did we hit here? Didn't we? Didn't we break out here? Did you like solid data throughout? I mean, more or less. That looks pretty good, not gonna lie. Yeah, it's okay. Not the best, but it kinda, well, it's okay today. I'm a little bit tired. So why do we exceed that? What did I do wrong here? And why? So let's add a watch here. Let's so that's sample count, right? Yeah. So is our Morton index corner 0 less than sample count? Can we cast that to uint? I guess not. Ah, where M? Okay. If that is all valid now, then I'm a little bit confused. Okay, good. Okay, 5, 6, and 7 is not valid. So what do we do if it's not valid? For example, 5. So 1 to the so 1 to the left is valid, right? Because we have that. Then up is not valid. You know what? For now, what we will do is we will cheat a little bit. 1, 2, 3, 4, 5, 6, 7. So if one of them is invalid currently, we would need to handle the case where basically it takes the sample of the edge instead of moving a full sample point out basically, but we will just continue and we ignore that because our sphere is anyways not on the edge, so we don't really care about that right now. And that is slow. That was kinda expected. But let's see if we ever get out there. Okay. We have something. Let's actually only do that once. So we move that as we're now out. Refactor extract method. Generate sphere mesh or extract sphere mesh. That's fine, it can be a member function. And now we do that once. We do that even here, maybe not, right? Maybe that's even not smart to do. Maybe we move that. Let's move that somewhere else. Let's move that into our volume. Where do we have that? Components maybe? No. Or is it here? Maybe it is here. So that's when our volume source is loaded. Then let's get rid of that for now. Hello, Captain Chica. How was your day? So I mean, it's pretty ugly, but what can you do? And then we go back to our worm. You were called a loco. I think it was loco, right? Okay. Alright, that sucks, I guess. What did you do? Okay, yeah. But, I mean... Some people do that, right? I wouldn't do that as far, but... Okay. For me, it wouldn't be warm enough, but... not really that comfortable with like the cold water, but yeah, I know that it's technically, I mean, well, it's still probably quite cold actually. Extract sphere mesh, and that's not good enough what I have here. So we basically get our CMS. And then we need the mesh builder as well, probably, because let's be honest, that is something we need. And then we do on volume loaded basically with our API. Basically our volume component. And the transform component and the mesh builder. So maybe we do a couple of things here like that, I don't know. Maybe we just iterate over one and then we instantly break. That chunk size. Don't really care about any of that. Do we care about any of that? Or no, we don't. Just do that, right? I got used to taking dips in a river with water temperatures of 12. Yeah, I mean, my girlfriend is the same. She was like always like in like seas in Austria or something like that. They are quite cold as well. But yeah, I'm not like that. I cannot do that. It's physically impossible, I tell you. So we want a mesh builder here. Now we get rid of that. And then let's brace ourselves for the most scuffed sphere probably there is. Because let's be honest, that will be something. What? Ah, the following warning is treated as an error. Let's do that, trick the compiler. So in theory that should now block quite a bit, yeah. And hopefully we get here eventually. And then let's see where we are. Okay. What is happening? Why is it not rendering anything? Or why is it blocking? Are we doing it again? Oh, what's happening? Why are we doing it again? Oh, actually, yeah, let's do that check here. Let's do it like that. And comment that out. And then we just break instantly here, and that's it. That should oh well, maybe not. That's why we do it all the time. Okay, well then probably the first time this is true, right? There is modified. Yes, okay. So if has modified or is modified is force return. So we only do it once. Otherwise we do this every frame. So now we should only trigger this once, hopefully. And then let's see what kind of Frankenstein mesh we get out of that. I don't expect this to work, to be honest. I would be so surprised if that works. I mean, I don't see anything. Although there is something there. But I don't think that's a sphere. Right? Is it maybe that... Hold on. What's my suspicion? Maybe we need to set the position to the transform for this to work. Maybe? Although that would be kinda weird, but maybe we need that. Did you see my... I think you saw it, right? Oh yeah, you wrote that weird... The funny... trickery with the... invisible space. Or Unicode shenanigans. That's like... crazy. But yeah, it was kind of funny to see. Okay, what did I just do? Why did I close it again? scene editor. Ha! Okay. So, hell to the no. Let's not do that. Well, we can do that, I don't care. Let's do vector 3. How about maybe... Okay, let's do something else. So if... word position. I start. Sorry, I will look at the chat in 1 second. I have it unfortunately somehow closed. Okay, so let's continue if it's not the 0 word position. Okay, so here's my chat. It actually works. It's not only on Windows, I think. Because I talked with the guy, because he's not really working at my company, but he's like from Austria, so. I think he said that it's like, it doesn't depend on Visual Studio or on the platform, but I'm not entirely sure anymore. I don't think it only works on Windows. But UTF-16, yes. That, yes. But I think Linux has as well UTF-16 or not. I'm not sure. I'm just saying that. Now, assuming that it does. Holy. Oh, that was a crash in my graphics card. Should I be concerned about that? If it happens another time, I might need to be concerned about that. Although I'm not doing something super crazy, I would assume. I mean, I'm just... Okay, no, maybe I am. Maybe I am doing something weird. Although I'm not quite sure what that would be, but... Let's see, what is my vertex and index buffer here? Maybe that's like garbage, I don't know. But I mean, how can that be? But that's fine still. That's as well still fine. Although that looks a little bit much, right? Maybe let's make it smaller for now. Maybe we don't extract in this fine detail, I don't know. Although, is it that small? Maybe we do at 2. No, 2 is too little. Let's do 4, I don't know. Okay, that still crashes. So maybe my vertex or index buffer is wrong, I don't know. That could be a thing, right? Or it's the normal. Let's actually put just, I guess, 0.f here. Let's just... Maybe it's the normal that we don't write in. That might be a problem. Although we have a normal in there. Right? I think we wrote the normal always. I mean, that looks fine. Although that looks kinda busted. Why would we have... No, that doesn't look correct actually. It looks correct up until this point, I would say. But this looks wrong. Because that doesn't look correct. So we do that, we get our line segments, we get our segments here, we get our components. And then we push our vertices here. And if one of them is not valid, we skip it. maybe our indices are out of like the bounds. So I mean we have 5,054 indices, right? I mean that looks all fine. Although that looks a little bit weird. Looks a little bit degenerated, the triangles. GCC. Okay. I mean, you explicitly said that it's not MSVC specific. It's the error that it gives. Oh, but are you using a normal space there? Because he uses a different, like, Unicode, right? It's not like the normal space. It's like a special Unicode character that looks like a space, but it's not a space. Yeah. No, it uses like a separate Unicode. Let me quickly find it again. Because he... Yeah, so here is the thread where he explains then how he did it. But yeah, it's just like for fun, right? He didn't, like, it was not a serious post. Let me post here. I posted it on Discord, but yeah, basically he has like a force include and yeah, does some stuff there, but yeah. And yeah, as you said, it compares on MSVC, Clang, and GCC, but yeah, was, as I said, just a... Yeah, exactly. But then your job is secured because no one can ever touch that file without knowing what he is doing. On the, you know, the secret, the secret characters for the types. It's called securing your job. So why would that be so weird? Ah, that will be a pain to find, I think. I mean, I guess we could put a breakpoint here and see what the vertices are that come out when he first adds. So we have 4 vertices. Okay. Hold on. What am I doing here? Why is that like that? Shouldn't it be like that just? Why is it like so weird? Leave written? What did the copy paste do there? Whatever. So let's see, we have our components here. And we have our vertices. Now we add 1. Which is now in our index, yes. And in our vertex map. And then we have that, which is 0. I plus 1 is the same as vertex count minus 1. What? Why would that be the case? Didn't we filter out duplicates? So he adds 0, which is this one. But those two are the same. Okay, so if those two are the same, I guess that makes it that it's not a line segment, but it's a dot. And in that case, let's just ignore it. And that's already kind of bizarre thing, but I mean, I guess. Let's guard that. Catch that one if you can. God damn it. Please no.